We are looking at section 3.3. It's on page 57 in your student journal. Today, if you look up on the board of what our learning goal is, we want to be able to use completing the square to write a quadratic in vertex form. Another thing we want to be able to do is to be able to use completing the square to solve quadratic equations. So first of all, what does it mean to be completing the square? Well, it's when you start with a binomial in this form of x squared plus bx, and you turn it into a perfect square trinomial. Turn it into a perfect square trinomial. A perfect square trinomial are the ones that I was checking you with earlier, where I was giving you like x squared plus 6x plus 9 and asking you to rewrite it. That's what is meant by a perfect square trinomial. Down here, it gives you directions on how to go about completing the square. To complete the square for the expression x squared plus bx, we just add b over 2 squared. I prefer to think of it this way. Take half of b, square it, and add it. You must keep the new equation equivalent to the original. That's what the book doesn't really tell you about right here, is that you must keep the new equation equivalent if you're doing any solving or rewriting. Here it just shows you in a diagram how it works. Let's go down here to the bottom now. So the vertex form of a parabola is this. It's f of x equals a times x minus h quantity squared plus k. So I want to write this in vertex form. We want to write f of x equals x squared plus 4x plus 5 in this hk form. So here's how we go about this. I'm going to have f of x equals x squared plus 4x. I'm going to move the 5 over a little bit. I'm not taking it over to the other side. I'm just kind of moving it out of the way. What I want to do right here is I want to create a perfect square trinomial. To create that perfect square trinomial, I have to add something. The something that I add is right here. Half of b squared. Right here's b. What's half of b? Half of 4 is 2, and now square it. 4. So I'm going to put a 4 here. But if I add 4 to this side, I also have to subtract 4 to keep it equal. Let me show you again what we did. We took half of this was 2, squared is 4. So I added 4 to my equation. But if I'm going to add 4, I also must subtract 4 to keep it balanced, to keep it the same as it was at the beginning. Can you see now how 4 minus 4 would cancel, and I still just have x squared plus 4x plus 5 like we did at the beginning? So now I'm just going to rewrite it. I'm going to group these three together. So now I'm going to have f of x equals, I want to know how this factors. This is what we did on the board earlier. So I do the square root of the first sign, and the square root of the last, quantity squared. That's how it factors. And then I just combine these two. So 5 minus 4 would be 1. And so now I have this in vertex form. Here's my h, here's my k. So now I can see that the vertex, if I needed to find it, would be -2, 1. But this is the vertex form that we were asked to find. Okay, I'd like you guys with your partner to try to do this one now. I'll be doing it up here if you get confused, but I want you to try not to look until the very end. Did you get it? Anybody need help or need to ask a question about how we got something? All right. So now we have this in vertex form. Let's say this is on the calculator part, and I don't feel confident that I have it in vertex form. I could do x squared plus 10x plus 28 on my calculator. When I look at it, here's the way it looks. The vertex, what's the vertex supposed to be here? Negative 5, 3. So I'm going to calculate the minimum. That's the same as the vertex. So I'm going to have to go to the left side of it, to the right side of it, and then I'm checking, and the vertex is negative 5, 3. So I know that's correct, because the vertex is correct. All right. Let's go over to the back. Solve the equations by using square roots. Check your solutions. We're not going to check. So to use square roots, this is like what we did on the board for the warm-ups. I'm going to group these three together. Okay, grouping those three together. Tommy, what's another way to write that?
X plus 2 squared.
So once I have that rewritten in factored form, now I have a quantity squared. So now I would be able to take the square root of both sides. So I'm going to take the square root here, square root here. The square root of a quantity squared is just what's under the squared symbol. I have plus or minus, and then I'm going to subtract 2. And just like with imaginaries, I want to put my my integer first and then my irrational number second, kind of like what we do with the complex numbers. Questions on that? All right, I want you guys to try number 3 now. And I'll tell you this is a perfect square trinomial. So use that same pattern. Okay, now hopefully you've gotten to this part where you've got 3w plus 1 equals plus or minus 3i radical 2. Does anyone need help getting to that point? Because I want to show you the rest of it together. So now what I have to do is subtract 1 from both sides. So I'm going to come up here so I have more room. I have 3w equals negative 1 plus or minus 3i radical 2. I have to divide by 3. Now watch what my final answer is. Look at this. This is a term. So I would have negative 1 is getting divided by 3. Plus or minus, and then I have 3i radical 2 that's getting divided by 3. See, this is getting divided by 3, and this is getting divided by 3. So what's 3i radical 2 divided by 3? Just I radical 2. And this would be our solution. What type of number is this? Imaginary number. Is it a pure imaginary number? No. All right. Let's go down here. Down in this part, we're just trying to find the value of c that makes the expression a perfect square trinomial. Then write the expression as the square of a binomial. Okay, so remember our pattern. All we have to do to find out how to make this a perfect square trinomial is to take half of this and square it. So what's c going to be, you guys? What is it? 49. And now you want to rewrite that as the square of a binomial. So like this, that's the square of a binomial. Kara, what's it going to be?
It's going to be y minus 7.
Good. All right, now on the next one, we want to do the same thing. We have to take half of 17. Do not call it 8.5. 8.5 is too difficult to square. You'd have to do 8.5 times 8.5. And so instead, we're just going to think of it as 17 over 2. That's half of it. And now I'm going to square that. And it's pretty easy to do. Because what's 17 squared? Well, it's easy to do if we know 17 squared. That's 289. So it's going to be, that's going to be 289 over 4. We just square this and square that. So now on your own, think of it what it would be as a binomial squared. Nick, what do you think? Take the square root of this, so just the s, right? And then use this sign. And then do you remember the square root of 289? Seventeen. And what's the square root of 4? 2. So there's that one. All right, and then go ahead and do this one on your own. Julia, what did you put in for C? And then did you get the binomial squared? Great. All right, awesome. So on these, we're not keeping it equivalent because it's just asking us to create a perfect square binomial, or trinomial rather. Okay, in exercises 7 through 12, solve the equation by completing the square. All right, so I'm going to go through this with you. I'm actually going to do number 9 with you, and then I'm going to have you go back and do the easier one, number 7. Any time we have something like this, we have to distribute this y first. So I'm going to distribute this. So y times y is y squared. Y times 1 is just y. Plus, I'm going to leave a blank, equals 3/4. I want to complete the square. So I want to take this coefficient. What's the coefficient here? What's half of 1? 1/2. And if I square 1/2, what do I get? 1/4. So I have to add 1/4 here, and I have to add 1/4 here. So now I have to rewrite this. So I have to do the square root, this sign, and the square root. Why did I add 1/4 here? Why didn't I subtract 1/4 here? It's on the opposite side, right? So to keep it equivalent, when I go back and subtract 1/4 from both sides, see how that would just go away? So to keep it equivalent, I had to add the 1/4. So this is this squared equals, what's this going to be? Just 1. So now what do I do to both sides? Take the square root. So the square root here is going to be just y plus 1/2. What do I put here? Plus or minus 1. So y is going to equal 1 minus 1/2 and negative 1 minus 1/2. Figure out what that would be. 1 minus 1/2 and negative 1 minus 1/2. Karen, what is it?
Half and negative 1/2.
Good. Lloyd's going to write as an improper fraction. Okay, work with your partner or on your own on number 7. See if you can get it. Okay, everybody get 3 plus or minus radical 11? All right, if you did not get it, check and see where your mistake is. When you add the 2, make sure you made that a positive 2. If I add 9 here, I add 9 here because they're on opposite sides. So if I went back and subtracted 9, they would both go away and I get what I started with. All right, let's go down to 11 now. Okay, what do I have to do first on 11? Distribute. Now, I should always get the x squared coefficient to be 1. If I'm going to complete the square, the x squared coefficient must be 1. So what am I going to have to divide through by? Yeah, I can divide the whole equation by 6. Now, before I even do this by completing the square, I could do it, but think if I took this 4 back over. Would there be numbers that multiply to be 4 and add to be 5? Would there be? 4 and 1, right? That means this can be factored. So I really would not want to use completing the square if I notice that it can be factored. Do you guys see why? If I had plus 4, I could factor it and get solutions. Let's go ahead and practice just completing the square, though, because this one's a little bit more difficult. Take half of this as 5 halves. What do you get if you square 5 halves? 25 fourths. So I'm going to add that to both sides. So now I have to rewrite this. I do the square root, I do this sign, I do the square root. I'm going to have to think of this as negative 16 over 4. What's negative 16 plus 25? 9. So it's going to be 9 fourths. Now what do I do to both sides? Square root. So I have x plus 5 halves equals plus or minus the square root of 9 is 3, square root of 4 is 2. So now I'm going to have 1.5 plus, or sorry, 1.5 minus 2.5. What's 1.5 minus 2.5? 1.5 minus 2.5. Negative 1. I would also have negative 1.5 minus 2.5. Negative 1.5 minus 2.5. Right, or I could think of it as negative 3 halves minus 5 halves. Maybe that's easier. Negative 8 halves, see how it would be negative 4? When I get nice whole numbers like that, integer answers, that means that we're actually going to have been able to factor if we would have noticed it. Whenever you get answers like this, you could have factored. When you get answers, actually this one could have been factored even because of those answers we got. This one could not have been factored. All right. This is always a typical ACT question where they'll ask you how this factors. This is a question that's meant to slow people down. It says, explain how the expression 4p plus 1 squared plus 8 times 4p plus 1 plus 16 is a perfect square trinomial. Then write the expression as the square of a binomial. This would be at the end of an ACT. People who are slow would never get to it. And even if you did get to it, it would probably slow you down unless you saw a trick to it. Does anybody see a way that I could make this problem easier? Karen?
Subtract 16 to the other side.
It's not an equation, though, so I can't take it over to the other side. If I were trying to solve it. Not allowed to. It doesn't say solve. It just says factor.
Multiply everything out and find
Okay, I could do that, but that's the way to slow you down. And if you had enough time, sure, you would do that. But look at this. What if I say that x equals 4p plus 1? What goes here then?
X.
So I'm going to have x squared plus what goes here?
8x.
All right. So now what does this turn into? X plus 4 squared, right? But what is our X?
What do you put in one? No way.
So see how that problem could take us forever, or it could take us about 10 seconds? Yeah. And I tutor people with ACT, and this is always something that's on the practice test, a similar type of problem, where if you just notice, hey, if I just let that be X instead of being that complicated thing, it's very easy to work with. Okay, so you want to watch for things like that. Okay, let's go over here now. Choosing the right method. Okay, here's what happens in math. We learn a new trick. And what do we want to do with that new trick? Use it every single time. We're not doing that anymore. We want to think of the best way to do the problem. Just because we learned how to complete the square doesn't mean we should every single time. For a problem like this, I should be looking at the fact that I only have 2 terms. That means I want to look for a greatest common factor. What can x squared and 7x both be divided by? So I'm just going to factor out an x. What am I left with then? X plus 7. So now I just set this equal to 0 and that equal to 0. There's 2 solutions. What are they?
0.
Right. Okay, I could have completed the square. I would have got the same answer, but you wouldn't want to. This is just so much easier just to factor an x out. We can't divide through by x. That's what some people say. Why don't you just divide by x? Why not? What kind of value is x? Variable. You can't divide by variables, only constants. All right, what would you do here? Would you complete the square? Just do what to both sides? Square root both sides. X minus 1 equals plus or minus the square root of 35. So x has to be 1 plus or minus radical 35. Don't waste time multiplying that whole thing out. What are you going to do on 16? Are you going to complete the square? What would you do, Carter? Not sure? Karen?
Add 20 to 25.
Yeah. Just take this over to the other side. Add it to both sides. Carter, now what could we do? Take the what? Yep, take the square root of both sides. Do you know the square root of 225, you guys, everybody? 15, so plus or minus 15. We're done. All right, what do you notice about this one? Divisible by 4. Am I allowed to divide by 4? Sure. Yes, I can. It's a number. It's an equation. If I'm dividing by a constant and it's an equation, I can divide through by it. So divide everything by 4. But are there numbers? See if it can factor. Are there numbers that multiply to be 3 and add to be 2?
Yes.
Multiply to be 3. 3 and 1. Is 3 plus 1 going to give me 2? No. What am I going to have to do? Now complete the square. I have to. Take over the 3. What am I going to put on both sides? 1. Good. Add 1 to both sides. What's another name for this? Quickly, guys. What is it? Yep, but what is it? X plus 1. This is negative 2. Now what? Take the... So I'm going to get x plus 1 equals plus or minus I radical 2. Bring over the 1. Okay? On your homework and on quizzes and on tests, I will never tell you you have to do a problem a certain way. Do it the best way, the easiest way. All right. With your groups, I want you guys to try 18 and 19, and then we're going to do 20 together. Take about 5 minutes. See if you can do 18 and 19. Okay, so for a lot of people I saw they have both of these answers, but when you check those, when I do -1 plus radical 21, I get a positive, but if I do -1 minus radical 21, I get a negative. You're only allowed to use the positive. So did most of you make that correction and only use that? What's radical 21 approximately? You know the square root of 16 is 4. You know the square root of 25 is 5, so what would this be about? 4.5, so -1 plus 4.5 would be positive. All right, how did we do on 19? Did you get 19? Do you remember from the beginning how we did this?
Yes.
So this one, we just scoot the 22 out of the way. What's half of 6 and then squared? Plus 9. Do I put plus 9 here? Minus 9 because they're on the same side. So then I'm going to have x plus 3, quantity squared, plus 13. So then my vertex form is going to be that. And, oh, it says to identify the vertex. Vertex is at -3, 13. Could we check that on the calculator? Yeah, we could check it. We could just be looking for this vertex, right? If I check it, though, I want to show you something. I try to check this. I do x squared plus 6x plus 22. I do my zoom 6. I'm looking for the vertex. I don't even see the vertex. Why am I not seeing the vertex?
Your window's not right.
Yep, I got to make my window go up higher because that vertex is at -3, 13. So I need to make this go up to maybe 20. And I'll see if I can see it. There it is. Looks like it's about there, but I could check it. Do second trace, calculate that minimum. Go over to the left. Just checking that vertex real quick and go to the right. Enter, enter, enter. And there it is, -3, 13. All right, last one, guys. A golfer hits a golf ball in the fairway with an initial velocity of 80 feet per second. The height in feet of the golf ball t seconds after it is hit can be modeled by this function. H of t equals -16t squared plus 80t plus 0.1. Find the maximum height of the golf ball. Which way does this parabola open? Up or down? Down. Maximum height of the ball will be the same thing as the what? Vertex. And in fact, it's the y value of the vertex, right? I need to find the vertex. Is my best method to do completing the square? No. I would go straight to the calculator here. We have large numbers. It's going to be pretty difficult. So I'm going to put in -16x squared plus 80x plus 0.1. If I do a zoom 6, I am not going to see anything. Maybe just a little tiny piece of that. Oh, there. Actually, I saw more than I thought I would. Okay, so I want to see the maximum height of the ball. It's way up there. Go to the window. Time is what x is. My least amount of time I could have would be 0. Most, maybe 10, I don't know. But the highest point might be way up there. I don't know, maybe 100 feet. Let's see. A little bit higher than that. Might make this y max. Might make it 150 just to be sure. That's pretty good. All right, so I'm trying to find that maximum height. We just do our second trace calculate, find that maximum. We go over to the left and over to the right. Make sure you hit enter after left bound. Enter after right bound. So is my highest point 2.5 or 100.1? 100.1 because the y's are the height. See how y is height? What's this axis representing? No, it's not the horizontal distance. It's t, which would be what? Time. So comparing time to height, that's what this is doing. So my maximum height is 100.1 feet. How do I find how long it's going to take the ball to hit the ground? Okay, I do want to know my x-intercepts, but what's the easiest way to find them? Put in y equals what? 0. And then hit graph, and I want to find right there where the ball hits the ground. Second trace, find that point of intersection. It says, is that your first curve? Enter to say yes. Is this your second? Enter to say yes. Enter one more time. This is my t, this is my time. So at 5.001 seconds, we'll round to the nearest 3 decimal places. That's how long it's going to take. All right, questions? Lots of stuff today. Basically, we want to know how to complete the squares, the big picture thing.